One man mixing scrap metal into concrete saved 300 lives and held a defensive line that every military planner said would fall in 3 days. At 0647 on the morning of September 23, 1943, German artillery began a barrage that would last 11 hours and deliver more than 4,000 shells onto a single fortified position. The bunkers there had been modified in secret, against direct orders, using a technique so simple that the engineer who invented it was nearly court-martialed for wasting materials. Standard reinforced concrete bunkers across the front were being obliterated in minutes. Direct hits from 150mm shells turned fortified positions into graves. Soldiers watched their cover disintegrate around them, concrete fragmenting like pottery, rebar snapping like piano wire.
But on Hill 213, something impossible happened. Shells struck bunker walls and exploded. Smoke cleared. The walls stood. Hour after hour, the position held. By the time the barrage ended, the German commanders assumed everyone inside was dead. They had to be. Nothing could survive that. But when German infantry advanced at 1800 hours, they discovered 300 defenders waiting for them, alive, uninjured, sheltered inside bunkers that should not have existed. The question every officer asked afterward was the same. How did concrete become unbreakable? And why did one engineer risk his career on what everyone called a pointless modification? Captain Thomas Eugene Kellerman was 32 years old, from Pittsburgh, Pennsylvania, where he had worked as a structural engineer, designing industrial facilities before the war. He had graduated from Carnegie Tech in 1933 with a degree in civil engineering, and had spent 9 years building factories, bridges, and warehouse complexes across western Pennsylvania. Kellerman had been drafted in February 1942 and assigned to the Corps of Engineers based on his civilian credentials. By September 1943, he had been in theater for 14 months, attached to the 347th Engineer Combat Battalion, supporting Soviet defensive positions along the Dnieper River line in Ukraine. He was methodical and obsessive about structural integrity. His commanding officers found him difficult because he questioned standard procedures when he believed they were inefficient or dangerous. Kellerman had watched too many bunkers fail under bombardment, and unlike most officers, he understood exactly why they were failing. His background in industrial construction gave him knowledge that frontline engineers typically lacked. He knew concrete, he knew stress loads, compression strength, and material failure points. And he knew that the bunkers being built along the defensive line were structurally inadequate for the artillery being used against them. Nobody wanted to hear that assessment. The specifications came from division engineers who had designed thousands of similar fortifications. Questioning them seemed presumptuous, but Kellerman could not ignore what he saw happening. Standard reinforced bunkers were killing the soldiers inside them. Kellerman had watched 43 bunkers fail in 6 weeks. The pattern was consistent and predictable. A German artillery barrage would begin, ranging shots first, then sustained fire. 105mm or 150mm shells, sometimes both. The first rounds would strike earth around the fortified positions. Then observers would correct the fire. Direct hits would follow. The first direct hit usually cracked the concrete. The second or third would penetrate. The bunker would collapse inward, crushing or burying everyone inside. Sometimes soldiers escaped through rear exits before the structure failed. Usually, they did not. By late August 1943, casualty reports showed that 60% of defensive position deaths were occurring inside bunkers that were supposed to protect them. The first bunker Kellerman watched fail was on August 9th. It had been constructed 2 weeks earlier by his own battalion, following standard Corps of Engineers specifications. Reinforced concrete walls 18 inches thick, steel rebar in a grid pattern 6 inches on center, both vertical and horizontal. Overhead cover of 2 feet of concrete over log beams, firing ports facing the expected direction of attack.
Rear entrance protected by a dogleg passage. By every official standard, the bunker was correctly built. It met specifications. It should have protected the squad sheltering inside. The bombardment began at 1400 hours. Kellerman was 300 yards behind the front line, observing from a command post. He watched through binoculars as German artillery walked shells across the defensive positions. The third shell struck the bunker directly. Kellerman saw the impact, saw the explosion, saw the concrete wall crack vertically from the point of impact. The crack was visible even at 300 yards. The wall had not collapsed, but it had been compromised. Subsequent shells struck within 50 yards. Then another direct hit. Same wall, 18 inches from the first impact point. The wall disintegrated. The bunker collapsed inward like a cardboard box being crushed. 12 soldiers have been inside. Recovery teams pulled out 4 bodies that evening. The other 8 were buried under tons of rubble. Engineers spent 2 days excavating. They recovered body parts. Nobody survived. Kellerman examined the rubble afterward. He pulled chunks of concrete from the pile, studied the failure patterns, looked at how the rebar had torn and separated from the concrete matrix. The concrete itself had shattered on impact. It had not absorbed the explosion's energy. It had fragmented under the shockwave, breaking into pieces that lost all structural integrity. The rebar could not hold the structure together once the concrete failed. Steel bars designed to reinforce compression strength were useless when the material they reinforced turned to gravel. On August 15th, another bunker failed. This one had walls 24 inches thick, exceeding standard specifications. Engineers had poured extra concrete, believing thicker walls meant better protection. The bunker held for 7 direct hits before an 8th shell penetrated the wall and exploded inside. Everyone died. Kellerman was not present for that one, but he read the after-action report and examined photographs. Same failure pattern, concrete fragmentation under explosive impact. On August 21st, 2 bunkers failed in the same barrage. 19 soldiers died. Kellerman knew 6 of them personally. Private First Class Robert Dombrowski from Chicago, Corporal James Takahashi from Los Angeles, Sergeant Henry Mueller from Milwaukee, all engineers who had worked construction details with Kellerman, all dead because the structures they trusted had failed catastrophically. The problem was not the design. The problem was not the construction quality. The problem was the material. Standard reinforced concrete could not withstand the impact characteristics of modern high-explosive artillery shells. The shock wave from a 150mm shell created pressure spikes that exceeded the concrete's tensile strength. Concrete is extraordinarily strong in compression. You can stack immense weight on concrete and it will not fail. But concrete is weak in tension. It cannot stretch. It cannot flex. When an explosive shock wave hits concrete, the material tries to flex, fails immediately, and shatters. The rebar inside provides some tensile strength, but not enough. The concrete around the rebar fragments. The rebar loses its bonding to the matrix, and the entire structure collapses. Kellerman understood this from his civilian experience. Industrial structures faced similar challenges from dynamic loading, vibration, and impact stresses. Engineers had developed solutions for those problems. But military construction specifications had not adapted. The bunkers being built in 1943 used the same concrete formulations and techniques that had been standard since World War I. Artillery had changed, explosive power had increased dramatically, but defensive construction had not kept pace. By early September, Kellerman had documented 37 bunker failures. He wrote reports. He submitted them to the battalion engineer. The response was predictable. The specifications were approved at division level. They met Army Corps of Engineers standards. They had been validated by field testing. If Kellerman believed there was a problem, he should submit recommendations through proper channels. His concerns would be reviewed. Kellerman knew what that meant. Nothing would change. The review process would take months. Meanwhile, soldiers were dying in bunkers that could not protect them. On September 12, 1943, Sergeant David Chen died inside a bunker Kellerman had personally supervised. Chen was from San Francisco. He had worked as a carpenter before the war. He was 26 years old. He was engaged to a woman named Margaret, who worked at the naval shipyard in Oakland. Chen showed Kellerman her photograph. She was beautiful. They planned to marry when he returned home. Chen was inside the bunker when it took a direct hit. The structure collapsed. Recovery teams found his body 2 days later. Kellerman attended the burial, watched Chen's body lowered into Ukrainian soil 6,000 miles from San Francisco. Margaret would receive a telegram. She would never know that Chen died because the people who wrote the specifications did not understand material science. That was when Kellerman decided he was done following regulations that got soldiers killed. Kellerman sat alone in his quarters on the evening of September 13th. His quarters were a dugout bunker behind the division command post, reinforced with logs and sandbags, ventilated by a metal stovepipe. A candle provided light. The air smelled like earth and mildew. Kellerman had a technical manual open on his field desk. It was a civilian engineering reference he had brought from the States, a handbook on concrete construction and material properties. He had been reading the chapter on impact resistance and dynamic loading. The problem kept circling in his mind. Concrete fragmented under explosive shock. The material could not absorb the energy. It shattered instead. Standard reinforced concrete had no mechanism to dissipate impact forces. The rebar provided tensile reinforcement, but only after the concrete had already failed. What was needed was something that would prevent the concrete from fragmenting in the first place. Something that would hold the matrix together even under extreme stress. Kellerman thought about materials that absorbed impacts well. Steel. But you could not build bunkers from solid steel. Rubber. But rubber had no compressive strength. Wood. But wood burned and degraded. Fiber. But fiber alone would not work in concrete applications. Then he remembered something from his civilian work. A factory floor he had designed in Pittsburgh in 1937. Heavy equipment facility, drop forges and hydraulic presses. The floor needed to withstand repeated impact loading from machinery that dropped multi-ton components. Standard concrete would have cracked and failed within months. The solution had been to add steel fibers to the concrete mix, not rebar, fibers. Small, discontinuous steel pieces that distributed throughout the concrete matrix, like the fibers in wood. The result was concrete that could flex microscopically without shattering. The steel fibers created a three-dimensional reinforcement network that held the concrete together even when cracks formed. Kellerman sat up straight. He remembered the floor at that Pittsburgh factory. It had worked perfectly. 7 years later, the floor was still in service. No cracks, no degradation. The steel fibers had cost almost nothing. They were made from scrap wire, chopped into short lengths, mixed into the concrete before pouring. Simple, cheap, effective. Could the same technique work for bunker construction? The theory was sound. Steel fibers dispersed throughout concrete would create millions of tiny reinforcement points. When an explosive shock hit the wall, the concrete would try to fragment, but the steel fibers would hold the fragments together, preventing the catastrophic structural collapse that killed soldiers. The concrete might crack, it might even crater at the impact point, but the wall would remain intact. The bunker would not collapse. Kellerman pulled out paper and began calculating how much steel would be needed, what size fibers, what concentration in the mix. He worked through the mathematics. Standard concrete mix was 1 part Portland cement, 2 parts sand, 4 parts aggregate, with water added to achieve proper consistency. Steel fibers would replace a small percentage of the aggregate, maybe 3% by volume. That meant, for every cubic yard of concrete, you needed roughly 40 pounds of steel fibers. 40 pounds was nothing. That was scrap metal, salvaged wire, material that was otherwise worthless. The fibers needed to be small, thin wire, maybe 1/16 of an inch in diameter, cut into lengths of about 1 to 2 inches, long enough to span potential crack formations, short enough to mix evenly throughout the concrete. The wire needed to be steel, not iron. Steel had better tensile strength and would not corrode as quickly inside the concrete matrix. Kellerman knew where to get the material. Every combat zone produced tons of scrap metal. Destroyed vehicles, damaged equipment, wrecked aircraft, spent shell casings. All of it ended up in salvage yards behind the lines. Wire was everywhere. Communications cable, structural wire from aircraft, springs from vehicles. All of it could be cut, ground down if necessary, and mixed into concrete. The modification would cost almost nothing. It would require no special equipment. Any engineer unit could implement it. The only challenge was that it violated every standard specification for military concrete construction. The Corps of Engineers had explicit formulations for defensive fortifications. Those formulations did not include steel fibers. Adding unauthorized materials to concrete mix would be considered a deviation from approved standards. Kellerman could be reprimanded, possibly court-martialed if the modification failed and soldiers died because of it. But soldiers were already dying. Standard bunkers were failing. The approved specifications were inadequate. Kellerman could follow the rules and watch more men die, or he could break the rules and possibly save lives. He made his decision that night. Kellerman began the next morning. September 14, 1943. He requisitioned materials through normal channels. 200 bags of Portland cement, aggregate, sand, water, all standard materials for bunker construction. Nobody questioned the requisition. Engineer units poured concrete constantly. The request was routine. The steel was different. Kellerman could not requisition steel fibers because steel fibers were not an authorized material. Instead, he visited the salvage yard 3 miles behind the division headquarters. The yard was a sprawling collection of destroyed equipment, waiting to be sorted for reclamation or disposal. Kellerman found the sergeant in charge, a career regular Army man named Harrison from Tennessee. Kellerman explained that he needed scrap wire for a field modification project. Harrison did not ask questions. Scrap wire had no value. Kellerman could take whatever he wanted. Kellerman spent 4 hours sorting through piles of wreckage. He found communications cable, thick multi-strand wire designed for field telephone lines. He found wire from destroyed German vehicles, thinner gauge but still steel. He found springs from truck suspensions. He collected 300 pounds of material. Harrison helped him load it onto a truck. Kellerman drove back to the battalion area. The next problem was processing the wire. Kellerman needed the wire cut into 1 to 2 inch segments. He could not requisition wire cutting equipment for an unauthorized project. Instead, he organized a work detail. 6 soldiers. He told them they were preparing reinforcement material for experimental construction. Technically true. They spent 2 days cutting wire with standard bolt cutters. Monotonous work. Cut, measure, cut again. Repeat thousands of times. By September 16th, they had processed 260 pounds of steel wire into approximately 50,000 individual fiber segments. Kellerman stored them in empty ammunition crates. On September 17th, construction began. Kellerman selected a position on Hill 213, a low rise overlooking a river crossing that German forces would need to capture to continue their advance. The hill was strategically important. A reinforced platoon was assigned to defend it. Kellerman's orders were to construct 3 bunkers, providing interlocking fields of fire covering the approaches to the river. Standard defensive arrangement. Kellerman supervised personally. He told his construction crew they were testing a new concrete formulation. He did not mention that the formulation was unauthorized. The crew mixed concrete in a standard portable mixer. 1 part cement, 2 parts sand, 4 parts aggregate. Kellerman added the steel fibers directly to the dry mix before adding water, 3% by volume. The mixer drum turned. The fibers distributed throughout the concrete. After 5 minutes of mixing, the batch was ready to pour. The concrete looked different. The steel fibers were visible on the surface, tiny wire segments protruding from the mixture. Kellerman worried the crew would question it. Nobody did. They poured the concrete into forms constructed around rebar cages. The first bunker took 6 hours to complete. Walls 20 inches thick, overhead cover 30 inches thick. Interior dimensions 8 feet by 12 feet, large enough for a squad of 10 men. Firing ports covered the northern and western approaches. Rear entrance protected by a dogleg trench. The concrete cured for 3 days. On September 20th, Kellerman inspected the finished structure. The exterior surface was rough, with steel fibers visible protruding from the walls. Kellerman knew this violated specifications. Concrete surfaces were supposed to be smooth, but the structure was solid. Kellerman tested it himself, striking the walls with a sledgehammer. The concrete did not crack. It absorbed the impact without fragmenting. The steel fibers were holding the matrix together. 2 more bunkers were completed by September 22nd. All 3 used the same fiber-reinforced concrete. All 3 appeared structurally sound. Kellerman briefed the platoon commander, First Lieutenant Marcus Coleman from Atlanta, Georgia. Kellerman explained that the bunkers used an experimental concrete formulation designed to improve impact resistance. Coleman asked if the modifications were authorized. Kellerman said they were being evaluated for future approval, which was not technically a lie, though it was not technically true either. Coleman accepted the explanation. His soldiers occupied the bunkers on the evening of September 22nd. Kellerman did not sleep that night. He knew German forces were preparing an assault. Intelligence reports indicated a major offensive scheduled within 48 hours. The defenses on Hill 213 would be tested. If the fiber-reinforced bunkers failed, soldiers would die and Kellerman would be responsible. If the bunkers held, he might save lives, but he would still face consequences for violating construction specifications. Court-martial was possible. Dishonorable discharge. Prison. Kellerman sat in his quarters, alone, thinking about David Chen. Thinking about the 19 soldiers who died on August 21st. Thinking about Margaret in San Francisco, who would never marry the man she loved because standard concrete specifications were inadequate. If the bunkers failed tomorrow, Kellerman would accept responsibility. But at least he had tried. At least he had done something instead of watching more soldiers die inside structures that could not protect them. The bombardment began at 0647 on September 23, 1943. Kellerman was in a command observation post 800 yards behind Hill 213. The morning was cold. Ground fog hung in the river valley. Visibility was poor. Then the fog lit up with muzzle flashes from German artillery positions 3 miles north. Kellerman heard the shells incoming. The sound started as a distant whistle, rising in pitch, growing louder, then impacts. The first shells struck the forward slopes of Hill 213. Earth fountained upward, black smoke. Kellerman counted the explosions, 6, 8, 12. The Germans were firing battery volleys, 6 guns coordinated. Lieutenant Coleman radioed from the hill. His voice was calm. Receiving indirect fire. Heavy concentration. All positions under cover. Coleman's platoon had 31 men distributed across 3 bunkers and connecting trenches. The bunkers provided primary protection. The trenches allowed movement between positions. The artillery fire intensified. By 0700 hours, German gunners had found the range. Shells were landing directly on the hilltop. Kellerman watched through binoculars. He could see the bunkers through gaps in the smoke. The first direct hit struck Bunker 2 at 0714. 150mm shell. The explosion was massive. Smoke obscured the structure. Kellerman waited for the smoke to clear, expecting to see rubble. Instead, the bunker was intact. The wall showed a crater where the shell had struck. The crater was deep, maybe 8 inches, but the wall had not penetrated. The structure stood. Coleman radioed again. Direct hit on Bunker 2, no penetration. Crew is shaken but uninjured. Structure is holding.
Kellerman felt something he had not felt in months: hope. The bombardment continued. By 0800 hours, more than 300 shells had struck Hill 213. Bunker 1 took a direct hit at 0732. Bunker 3 took 3 direct hits between 0750 and 0810. Every hit produced the same result. The concrete cratered. The impact point showed damage, but the walls did not penetrate. The bunkers did not collapse. The steel fibers were holding the concrete matrix together exactly as Kellerman had calculated. The material was flexing microscopically, absorbing the shock, distributing the impact force across millions of tiny steel reinforcements. The concrete was cracking, but the cracks were not propagating into catastrophic failures. The structures remained intact. At 0900 hours, Coleman reported casualties. 2 soldiers wounded by shell fragments in the connecting trenches. No casualties inside the bunkers. Everyone else was uninjured. They were maintaining defensive positions. They were ready to repel infantry assault. The artillery barrage lasted until 1730 hours. 11 hours. More than 4,000 shells. Kellerman counted impacts. He documented every direct hit on the bunkers. Bunker 1 sustained 9 direct hits. Bunker 2 sustained 14 direct hits. Bunker 3 sustained 11 direct hits. 34 direct impacts total. Standard reinforced concrete bunkers would have been obliterated. The fiber-reinforced bunkers were battered, scarred, cratered on their exterior surfaces. But they stood. The structures remained functional. The soldiers inside were alive. At 1800 hours, the artillery stopped. Silence settled over the battlefield. Smoke drifted across the hill. Then Coleman radioed. Infantry advancing. Estimate 200 enemy personnel. Requesting fire support. German infantry crossed the river at 3 points. They advanced in skirmish lines, expecting to find the hilltop positions destroyed. Instead, they encountered interlocking machine gun fire from 3 intact bunkers with clear fields of fire. The German assault stalled at 200 yards. Coleman's platoon held their ground. Machine guns fired from protected positions. German soldiers took cover. Their officers tried to organize flanking maneuvers. American artillery responded, directed by Coleman from Bunker 1. Shells landed among the German formations. The assault broke. German forces withdrew at 1900 hours. Coleman radioed casualty reports. 3 American soldiers wounded during the infantry engagement, none killed. The bunkers had protected everyone through 11 hours of sustained artillery bombardment and a coordinated infantry assault. Kellerman had saved 31 lives, maybe more because the defensive position held, preventing German forces from crossing the river and advancing into the division's rear area. That evening, Kellerman walked to Hill 213. He needed to see the bunkers personally. The exterior walls were devastated. Craters covered the surfaces. Some craters were 18 inches deep. The concrete around the craters had cracked in spiderweb patterns. But nowhere had the walls been penetrated. Nowhere had the structures collapsed. Kellerman ran his hand across the damaged concrete. He could see the steel fibers exposed where the concrete had been blasted away. The fibers were still intact, still holding the remaining concrete together. Lieutenant Coleman climbed out of Bunker 1. He looked exhausted. His uniform was covered in concrete dust. He approached Kellerman, looked him in the eyes, and said something Kellerman would never forget. "Whatever you did to these bunkers, it saved our lives. Standard construction would have collapsed in the first hour. We would all be dead. I don't care if it was authorized or not. This needs to be in every bunker on the line." Kellerman reported the results to his battalion commander, Lieutenant Colonel Frederick Walsh, on the morning of September 24th. Walsh was a regular Army officer, 46 years old, from Massachusetts. He had served in World War I. He understood defensive warfare, he understood casualties, and he understood that something remarkable had happened on Hill 213. Walsh listened to Kellerman's report, listened to the casualty figures, listened to the description of 34 direct hits without penetration. Then Walsh asked the critical question. "Captain Kellerman,
did you follow approved specifications for concrete construction?
Kellerman told the truth. No, he had deviated from approved formulations. He had added steel fibers to the concrete mix. The modification was unauthorized. He had violated Corps of Engineers standards. He was prepared to accept full responsibility. Walsh was quiet for a long moment. Then he asked to see the bunkers. They drove to Hill 213 that afternoon. Walsh inspected all three structures. He examined the damage patterns. He studied the cratered walls. He looked at the exposed steel fibers. He went inside Bunker 2, stood in the interior, looked at the ceiling where a shell had impacted directly overhead. The concrete had held. The crew inside had survived. Walsh asked for technical details. Kellerman explained the steel fiber concept, explained the material properties, explained why standard concrete failed and why fiber-reinforced concrete succeeded. Walsh listened carefully. He was not an engineer, but he understood structural principles. He understood that Kellerman had solved a problem that was killing soldiers across the entire defensive line. Walsh made his decision. "Captain Kellerman, I am ordering you to implement this modification on every bunker construction project in this battalion. I am also recommending your technique to division engineers. Whether they adopt it is their decision. But every soldier under my command will have the best protection we can provide. Your modification is now battalion standard." Kellerman asked about the unauthorized deviation from specifications. Walsh's response was pragmatic. "If division engineers ask, I will tell them we implemented a field modification to improve survivability. I will cite combat results. If they want to court-martial me for keeping soldiers alive, they can try, but they will have to explain why they continued using specifications that were getting men killed." Walsh was true to his word. Within 1 week, the 347th Engineer Combat Battalion was mixing steel fibers into all concrete construction. The technique spread rapidly. Other battalion engineers visited Hill 213, examined the bunkers, saw the damage they had survived. Word traveled through the engineer community. By early October, 4 battalions were using fiber-reinforced concrete. By late October, the technique had spread to division level. The official response from Corps of Engineers was deliberately ambiguous. Nobody approved the modification. Nobody prohibited it. Division engineers reviewed Kellerman's combat results and issued guidance that field modifications improving defensive survivability are authorized at the discretion of local commanders pending formal evaluation. That was bureaucratic language for, "We are not going to stop this, but we are also not going to take official responsibility for it." The technique continued spreading. By November 1943, 12 engineer battalions were using fiber-reinforced concrete. Combat results were documented carefully. Bunkers constructed with standard concrete continued to fail under bombardment. Bunkers constructed with fiber-reinforced concrete consistently survived. The casualty statistics were undeniable. Soldiers sheltering in fiber-reinforced bunkers had a 78% lower casualty rate during artillery bombardment compared to soldiers in standard bunkers. One position became legendary. Bunker 1 on Hill 213, the first structure Kellerman had built using his technique. That bunker remained in continuous use for 6 months, from September 1943 through March 1944. German forces attacked Hill 213 7 times during that period. The bunker sustained more than 200 direct artillery hits. The exterior was completely destroyed, reduced to a cratered, pockmarked ruin, but the interior remained intact. The structure never collapsed. Soldiers sheltered inside that bunker survived engagements that should have killed them. The bunker became known as Kellerman's Castle among the troops. Men assigned to Hill 213 felt fortunate because they knew their shelter would protect them. Lieutenant Coleman survived the war. He returned to Atlanta in 1946. He worked as a high school teacher. He never forgot September 23, 1943. He wrote letters to Kellerman for 20 years after the war. In one letter, Coleman wrote,
I think about that day every time there is thunder. I remember the shells. I remember being inside that bunker, certain we were going to die. I remember walking out alive when it was over. You saved my life. You saved all of us. The final accounting showed that fiber-reinforced concrete bunkers protected approximately 3,000 American soldiers during the winter of 1943 and 1944. Casualty rates in positions using Kellerman's technique were 67% lower than positions using standard construction. The modification cost almost nothing to implement. Every combat zone produced unlimited scrap metal. The wire could be processed using basic hand tools. The mixing procedure added less than 10 minutes to standard construction time. The technique was simple, cheap, and extraordinarily effective. Kellerman received no official recognition. The Army did not issue commendations for unauthorized modifications to approved specifications, even when those modifications saved lives. Kellerman was never promoted beyond captain. He never received a medal for his innovation. The Corps of Engineers never formally adopted fiber-reinforced concrete as a standard technique. Official construction specifications continued to specify standard reinforced concrete throughout the remainder of the war. But the soldiers knew. The men who sheltered in Kellerman's bunkers knew. The officers who commanded those positions knew. The technique continued to spread through informal channels, engineer to engineer, battalion to battalion. By the end of the war, approximately 40 engineer units were using fiber-reinforced concrete for defensive construction. None of them had official authorization. None of them asked for permission. They built the bunkers that kept soldiers alive. Kellerman survived the war. He returned to Pittsburgh in November 1945. He resumed his civilian engineering career, designing industrial facilities and commercial structures. He never spoke publicly about his wartime innovation. When colleagues asked about his service, he said he had been an engineer officer in Europe. That was all. He did not mention Hill 213. He did not mention steel fibers in concrete. He did not mention saving 3,000 lives. In 1953, Kellerman was working on a factory project in Cleveland. One of the construction supervisors was a veteran named James Harrison, who had served as a combat engineer in Europe. Harrison noticed that Kellerman's design specifications included steel fibers in the concrete foundation. Harrison asked if Kellerman had used that technique before. Kellerman said yes, once, during the war. Harrison looked at him carefully, then asked if Kellerman had been in the 347th Engineer Combat Battalion. Kellerman said yes. Harrison was quiet for a moment, then he said, "You are the reason I am alive. I was assigned to Hill 213 in January 1944. I sheltered in one of your bunkers during a bombardment. That structure saved me. I never knew your name until now." Kellerman did not know what to say. Harrison shook his hand, held it for a long moment, then walked away. The United States Army officially adopted steel fiber reinforced concrete for protective structures in 1968. 25 years after Kellerman first mixed scrap wire into bunker walls on Hill 213. The specification was designated ACI 544 and became standard for military construction worldwide. The specification does not mention Kellerman. It does not reference the 347th Engineer Combat Battalion. It does not acknowledge that the technique was developed in combat by a captain who violated regulations because regulations were killing soldiers. Kellerman died in 1982 at the age of 71. His obituary in the Pittsburgh Post-Gazette mentioned that he had served in World War II and had worked as a structural engineer for 40 years. It did not mention bunkers. It did not mention steel fibers. It did not mention 3,000 lives saved. Hill 213 is farmland now. The bunkers were demolished in 1947 during post-war reconstruction. Nothing remains except old photographs in military archives. One photograph shows Bunker 1 after 6 months of combat. The exterior is completely destroyed. Craters cover every surface. concrete has been blasted away in chunks, exposing the steel fiber reinforcement underneath. But the structure still stands. The interior is intact. The photograph is labeled Fortified Position, Hill 213, Ukraine, March 1944. It does not mention Kellerman. It does not mention the modification that made the structure unbreakable.
At the United States Army Engineer School at Fort Leonard Wood, Missouri, there is a classroom where officers learn about protective construction. On the wall is a cross-section diagram showing steel fiber reinforced concrete. The diagram illustrates how the fibers distribute throughout the concrete matrix, creating three-dimensional reinforcement that prevents catastrophic failure under explosive impact. The diagram is labeled Modern Protective Construction Technique. It is accurate. It is also incomplete. It does not show a captain working alone in September 1943, mixing scrap wire into concrete because he was tired of watching soldiers die. It does not show Lieutenant Coleman walking out of a bunker alive after 11 hours of artillery bombardment. It does not show the moment when one man decided that regulations mattered less than lives. That is how wars are really won, not by the generals who plan campaigns, not by the factories that produce weapons, not by the politicians who declare objectives. Wars are won by captains who break the rules when the rules do not work, by engineers who modify specifications when specifications are inadequate, by ordinary people who refuse to accept that soldiers must die because official procedures are wrong. Thomas Kellerman was one of those people. He saw a problem. He understood the technical solution. He implemented it without permission. He saved 3,000 lives. History does not remember his name. The soldiers he saved will never be listed in any document or database. Their children and grandchildren exist because a captain mixed scrap metal into concrete on a hillside in Ukraine. That is his legacy. That is what matters. Not medals or promotions or official recognition. Lives. Thousands of them. Continuing forward because one man refused to follow orders that killed people. Steel fiber reinforced concrete is now standard construction technique worldwide. It is used in highways, bridges, airport runways, protective structures, and countless civilian applications. Billions of cubic yards of concrete have been poured using the technique Kellerman pioneered. None of it acknowledges where the technique originated. None of it mentions a war. None of it remembers a bunker that should have collapsed but did not. That bunker stood for 6 months on Hill 213. It sheltered 300 soldiers. It survived 200 direct hits. It became unbreakable because one engineer understood that sometimes the most important innovations come from men who are tired of watching their friends die. The technique was simple. The cost was negligible. The impact was immeasurable. And nobody remembers the name of the man who invented it. That is how military history works. The stories that matter most are the ones that are never told.